Alright, this video is dedicated to Haley, and this one's going out for the example 10.1 in the notes. So what's going on here is the swimmer is swimming through the water, and we're not required by College Board to know how to calculate drag force, but I did go ahead and do that for this particular problem. When I actually cover this in class, what I do here is I just say, hey, look, that's how they calculated the drag force. It's 35 or so newtons. I don't know, I don't recall what they use for the density of water off the top of my head, but it's about 1,000 kilograms per meter cubed, depending on the temperature of the water, but that's close enough for what we're doing here, and just go through and calculate all the things there, and you get 35. Again, this is none of this stuff over here, the drag force, that's not something you need to know for AP Physics 1. Um, Realistically, they would have to give you like the drag force if they wanted you to do this type of calculation. Now, with that said, our swimmer is moving through the water, and the question is simple enough: how much energy is it going to take to do that for a kilometer? And if you've never swam a kilometer before, you should try it sometime. Um, Nonetheless, basically, the drag force is always going to oppose your direction of motion when you're swimming through fluid or whatever. Air resistance is the same deal as the resistance from the water. It's always going to directly oppose your motion. So even though we kind of talked about this as like a displacement in class, it's really distance will apply as this thing is going through a fluid, because it's just however far you travel through the fluid, that resistive force will always push on you in the opposite direction that you are moving. So the fluid will actually do, the drag force will actually do negative work on you. Now, the way this question is phrased is how much energy is required. So the swimmer is going to have to use an equal amount of energy to that negative work that's done by the fluid. So I'm not putting any negative signs in the equation, because I'm solving really what I'm solving. Here's how I'm going to say this. I have a really simple way to do this, is that energy equals the absolute value of the work done. And there you go. Okay, cool. So anyways, with all of that hand waving aside, you can't see me waving my hands, but I would have waved my hands if we were in class. And we're just going to plug in the force. And the distance, which was 1 kilometer, to be compatible with newtons to get joules, you need that in meters. So you get newtons times meters, which is a joule. 1,000 meters. And that is going to give you 35,000 joules. Now, through the magic of pausing the video, I decided to be a little bit extra, because I was like, how many food calories is that equivalent to? And I was shocked by the answer, because it's really not a lot. It's only 8.4 food calories to overcome that drag, the work, the energy necessary to overcome the drag force. Now, a couple of reasons for that, at least what I can think of. One, this drag coefficient is probably way too low. Like, it probably should be at least double what it is. This would be, I don't know, like probably more like some fish that would have a drag coefficient of 0.45 in the water. But anyways, the other issue here is that your body's having to do more than just overcome the resistance of the water. It's having to move legs up and down and arms around, and maintain body temperature. So burning or excuse me, swimming for a kilometer, you would probably burn more like 500 food calories. That's why if you ever swim a lot, you're really hungry afterwards. Um, but just on the mechanical moving the water out of the way due to drag keeping you from being able to pass through the water uh, without some amount of resistive force is just 8.4 calories, which is really, well, by this bad drag coefficient. The other numbers are reasonable, by the way, but that particular drag coefficient, that's a little too low, but still, if you had a more reasonable drag coefficient, you'd probably be around 30 calories, and that's still a far cry from the 500 or so that you would probably actually burn going for that swim. So, hope that's helpful, and thanks for watching.